Good evening, all of you. Good evening, all of you. Let everyone join. I'll start the class. All of you joined? Any doubts so far? Are you on?
No, miss.
Okay.
No, miss.
Mhm.
Good night, miss.
Good evening. Shall we start or shall we wait for a few more minutes? Okay. So yesterday we have discussed about the different types of cables. That is your twisted pair cable and coaxial cable. Today we'll start with the fiber optics cable and microwave satellite communication we'll discuss today. So what do you mean by optical fiber cable? As we have discussed yesterday also about this, it looks like this fiber optics cable. So fiber optics is nothing but a technology. Okay, using the technology, we are transmitting a data from one device to another device. And the technology uses a short light pulses along a long fiber. If you have a long fiber cable, through that cable, we can able to send the data using the short light pulses, which is typically made up of glass or plastic. And whenever we are sending the data, the total internal reflection of light is used in the fiber optical cable. So there is a internal reflection of the light because it's a made of glass, right? So obviously, whatever we are sending, whichever light we will send, that is usually for reflection. Okay, obviously, when there is a light passing through the glass or light is um, falling on the glass, it will reflect, right? So obviously, when there is a total reflection of light is used in the fiber optics cable. Depending on the amount of power needed and the distance needed, the fiber optic cables are designed so that it will be used to allow light to travel in parallel with the fiber optics. With multi-mode fiber, what is multi-mode fiber? There are different mode, single mode, multi-mode like that. Okay, so multi-mode fiber is used for transmission over short distances and single mode fiber is used for long distances. Okay, and these fibers outer covering requires better defense that than your metal wire can provide. Okay, we have used the copper wires and all. That is, than that, the fiber optic cable is more good. Okay, proven that it requires better defense than the metal wire can provide you. Types of fiber optic cable: the refractive index, materials, and mode of light propagation all affect the types of fiber optic cable. Okay, so the refractive index, this is a different factor in the fiber optics cable. The refractive index, materials, and the mode of light which you are propagating is going to affect the types of optical fibers. In terms of refractive index, okay, how? In the terms of refractive index, the optical fibers can be classified into the following. In the terms of what one? Which one? Refractive index. Okay. So step index fibers here we have, graded index fiber here we have. Step index fiber means a fiber has a single uniform index of refraction and is made up of core encircled by cladding. Okay. So anyhow, we will discuss about the cladding and all in the later slides if you can see what is cladding and all. But as of now, you understand that here we have a fiber which has a single uniform index of refraction. Okay, and it's made up of the core encircled by cladding. So graded index fibers, as the radial distance from the fiber axis increases, the refractive index of the optical fiber decreases. Okay, so it is called as graded index fibers. In terms of material, right, in terms of refractive index, we have seen same we will see in terms of material, the classification is as follows. One is polymethyl methacrylate is used. This is a material here we are using as a core material, basic material in the plastic optical fiber which transmits the light. It is made up of incredibly fine glass fibers. So they're talking about the material in the fiber optic cables used. One is this material, which is a core material for traveling the light or for passing the light from one location to another location. It is made up of incredibly fine glass fibers over here. Now, classification in terms of mode of propagation. Here we have seen, right, refractive index, materials, and mode of light propagation. So now we are saying about the classification in terms of its mode of propagation. One is single mode fibers and the one is multi-mode fibers over here. Single mode fibers. Now these fibers are used to transmit the signals over the long distances we have seen. We have understood in the before slide also. Single mode fibers are used for long distance communication, wherein the multi mode fibers are used to transmit the signals over short distances. For short distance communication, we use this multi mode fibers. Now, the following four combination types of optical fibers are made using the mode of propagation and refractive index of the core. This is a combination. Here we have seen the individual. One is for refractive index. We have seen step index fibers and the one is graded index fibers. In terms of material, we have seen this. Now, material and all is a common one. This is a general one, every optical fiber. But the combination of the mode of propagation and the refractive index, combining these two types, okay, we have some more types, combination, okay, hybrid mode, okay, hybrid type of optical fibers. So hybrid types of optical fibers, if you see, step index, single mode fiber, graded index, single mode fiber, step index, multi-mode fiber, graded index, multi-mode fiber. So here we have single mode fiber and multi-mode fiber, and here we have the step index fiber and the graded index fiber. So step index using the single mode fiber, step index using the multi-mode fiber. Same way graded index use the single mode fiber and the graded index multi-mode fiber. Okay. Okay. Now, these are the basic terms which we have to understand while we are learning this optical fiber cable. And these are the basic terms which are used in the construction of optical fiber cable. The first one is core, and then we have cladding, coating, okay, ball spring fibers, cable sleeve, outer jacket. So all this we are going to learn because these are the basic terms which we have used while constructing the optical fiber and we should know about it. So this is the core if you talk about. This is the actual physical channel which carries the optical data signals from a connected light source to the receiver. Okay, so this is actually the physical channel here we have. Core is nothing but the physical channel, physical medium where we are transmitting a data using which we are transmitting a data from one location to another location. Thus, this is the actual carrier we can say. This is the actual channel as the carrier which is carrying the optical data signals in the form of light from the connected light source. That means from the source to the destination. Okay, it is carrying the optical data signals in the form of light from the source to destination. This is the actual channel here we have, which actually transmission is going on, where actual transmission is going on. What is the diameter of the core? The diameter of the core, which is a single continuous strand of glass or plastic, is measured in microns because here we have the collection of the uh, glass and the plastic, we'll say, no, small chunks. If you can see this, you could able to understand, made up of plastic or glass, and here tiny glasses, tiny particles of the glass or the fiber, plastic fibers we have used in this as we have discussed already. Okay, so now in the core, what they are saying, it's a which is a single continuous strand. Single continuous strand is like this, single wire you are saying like this, right? So this is a single continuous strand because we will see how many strands here we have. Okay, and every strand is responsible for carrying the light of pulses, if you can see here, right? So that is what they are saying over here. It is a core. It's the diameter of the core, which is a single continuous strand of glass or plastic, is measured in microns. The cable can carry more light the larger the core size is. The core size is more, you can able to transmit a large amount of data. Okay, the cable can carry more light the larger the core size. Okay, the outside diameter of each fiber optic cable diameters the determines the cable size. So if you see the cable, okay, the width of the cable, diameter of the cable, if it is more, then we can say, okay, fine, we can say the outer diameter of the wire is actually determining the size of the cable. Okay, if it is a thick wire, we can say the size of the cable is big and it can able to carry large amount of light, large amount of data. Okay, the three most widely used multi-mode sizes are multi-mode for short transmission, for short distance communication. That is what they are saying. The core which is used in the multi-mode. There are multi-mode sizes over here. 50, 62.5 and 100 microns. In terms of microns, we have to measure. That's the reason you can see 50, 62.5 and 100 microns. In general, single mode cores are less than 9 microns. So single mode, which is used for the large distance communication. So these cores are having less than 9 microns. Cladding. This is a thin coating that covers the fiber core, acts as a barrier and reflect light waves, allowing the information to travel the entire length of the fiber segment. So this cladding is nothing but here we have. This is the core where actually data transmission is going on. And this is the cladding which is covering this core. And this cladding is a thin coating which covers the cable. Okay, fiber core. Core is nothing but is your wire, the cable using which are made up of glass or the fiber plastics. Okay, so that is a core here. So it is covering the fiber core with the thin coating or as cladding. What is the use of it? It acts as a barrier. Okay, and this is the one who is reflecting the light waves and allowing the information to travel the entire distance, which has to be covered by the fiber optics cable, entire length of the fiber segment. That is called as cladding. So it's a thin coating which covers the fiber core. Fiber core act as a barrier which is actually reflecting the light, allowing the information to travel. Then we have, if you can see, then we have coating. After cladding, we have the coating over here. Now, coating is nothing but this plastic coating covers the core. Okay, again, we have one more type of coating on the uh, core, this fiber core. After cladding is a plastic coating. It covers the core and the cladding together. You can see it is covering both my cladding also and the core also, right? To fortify and safeguard the fiber core. Coatings might be anywhere between 250 microns and 900 microns thick. Okay, it's called as coating. What is the use of coating? To fortify and safeguard the fiber core. Okay, we are giving the security, we are safeguarding the fiber core using the plastic coating cover on the core and the cladding. Bolstering fibers, strength member. Okay, this is what called as strength member. The other name of the strength member over here is bolstering fibers. Now, during installation, these parts aid in defending the core from crushing forces and too much stress. If you can see when they are installing the cables underground and all, you can see they will put lot of stress. They'll handle without care. Okay, and too many crushes will be there. They'll hold very tightly. They'll roll like this. It's a stress we are giving to the cable. It's a lot of crush, lot of pressure. Okay, handling without any care is happening. So this handling without care kind of activity can damage the wire, can affect the communication. So there is a strength member called as bolstering fibers. Now these parts are defending the core from crushing forces. That means it is not allowing the that is not allowing to affect the core. It is somehow safeguarding the core from the crushing forces and too much stress. The material can be made up of Kevlar, wire stands, or sleeves filled with gel. Okay, this is what the materials they are using for the blaster fibers to increase the flexibility, decrease the rigidness, which again helping the core from crushing forces or helping or defending the core from crushing forces and too much stress. Cable sleeve. Any cable's outer layer is this. Okay, that is what outer jacket. If you can see, this is the outer jacket of the entire core cladding, and the here we have strength member. So it's the outer jacket. Any cable's outer layer is this. Although some varieties of fiber optic cables can have black or yellow jackets, the majority of them have orange ones. So these are different colors of the jacket here. We have the outer layer. Okay, we have different colors for that. So this is the construction. This is how the fiber optics cable are designed. Any extra informations do you want on this? Is it clear by everybody? Okay, if it is clear, hoping that is clear for everybody, I'm proceeding with the next one, which is called as advantages of optical fibers. Now, nowadays, at present, we all are using the fiber optics cable only than your twisted pair cables and the coaxial cables. These are outdated. Majorly, we are using the optical fiber cables only. So when you're using the optical fiber cables, there are a lot of advantages why we have shifted from the in there's a conventional method to the this method. Okay, so this is actually the first advantage over here is increasing the bandwidth and speed. The bandwidth and speed is too high, exceptionally high. The bandwidth means the amount of data you are sending at one time. Okay, the amount of data, how many people, for example, I have a school bus. I have to send my students to from my school to one place. Okay, today they have a field trip. So from this school, I have to send to the particular location for the field trip. So the capacity of the bus, for example, 50. Okay, so how many students I can send at a time? 50 students I can send because 50 chairs, 50 seats is available in the bus. Nobody should stand. So 50 members, 50 students I can send at a time to my location. If the size of the bus is very big, for example, I have the capacity of 80 members. Suppose double decker bus is there. Okay. So 80 members. So how many students I can send from one location to another location at a time? 80 students. Right? So this is what the bandwidth is. How much amount of data you can carry, you can send from one location to another location. Bandwidth is high. It can able to carry a large amount of data at a time, and the speed also too high. Light travels very fastly, right? 10 sound. So light speed is very high. That's the reason the speed of the optical fiber cable can offer are exceptionally high. Now, its most important benefit, the most important benefit is a high amount of information that can be carried per unit of optical fiber cable. That's what I said. At a time, a huge amount of information can be sent. This increases the faster, speedy in the delivery of the information. Then we have cheap. Optical fiber cable may be produced in long, continuous miles for less money than copper wire for of comparable lengths. Okay, fiber optic cable is produced in the longer distance. Okay, longer continuous miles and miles of distance that can be done using a single mode fiber optics cable here we have. So as we have discussed that it's used for long distance communication. So long distance, when I say It is a very huge distance it can cover, continuous or miles, for cheaper, in cheaper money, or we can say for less money than copper wire of comparable lengths. If you compare the length which is going to cover by the copper wire and the fiber optic cables, the fiber optic cables for that distance is not possible at all. If it is possible also, it becomes too costlier. But when you talk about the fiber optic cables, the same distance can be covered with the less costlier, less money. The cost of the optical fiber cable would undoubtedly decrease as more manufacturers swam to compete for market share lightweight. So this that cost also is decreased because many of the manufacturers or competitors are there. So that's the reason it has become cheaper than the copper wire. Light and thin. So optical fiber is lighter and thinner if you compare with the coaxial cable or the twisted pair cables and all. If you can see also in the image also it is showing, you see the cable is too thin. See, it's very thin. It's not like here we have, and this also, if you can able to see, or this cable you can see, this is a cable here we have. It's very thin compared to the coaxial cable or the fiber. See the coaxial cable, it's little thicker, and the here we have the twisted pair cable also, it's also thicker, right? But if you talk about the fiber optics cable, it is more thinner than the conventional methods, whatever conventional cables whatever we have, right? So it's lighter and thinner and lighter also, light in weight, and it may be drawn or to smaller diameters. They offer a better match for locations where space is an issue because they are lighter and smaller than comparable with the copper wire cables. Obviously, if I have very less space, for example, and I have to install the wires of fiber optic cable in those areas where I have very less space. There also it can able to accommodate because it is thinner in size and lighter also. Smaller comparable with the other conventional methods or the copper wire cables. Greater carrying capacity. It can able to carry a huge amount of data. Okay, so optical fibers may be grouped into cables of a given diameter since they are significantly thinner than the copper wires. So this enables extra phone lines to use the same cable or the more channels to enter your cable TV box through the cable. So you can see nowadays, the same, for example, if I have taken, I am telling my example in my country, what I have in my home. So if I have taken the internet connection from the Airtel company, okay, they are the providers for me who are providing the internet, for example, Airtel. The same cables are using for my internet also, and the same cables are used for my TV box also. They are giving the TV setup box nowadays, and the same connection will be used for watching the different channels in the TV. They'll give a setup box, and it's not like a very few number of channels. We can have more number of channels in the television to watch. The same connection, same wires, whatever they have installed in my home through these cables will be used for the internet purposes also, and for watching the channels in the television also. That's what they are saying. Greater carrying capacity. They can able to carry a huge amount of data, different types of data at a time using the fiber optics cable. So this enables the extra phone lines to use the same cable or more channels to enter your cable TV setup box through the same cable. So in your country, have you seen this? Any example can do you want to share with me? In your country, any example like this? The same internet providers are providing the internet also, and the setup box, the TV channels also. No? Yes, no, something you should say no. No? Okay. So this is what will happen in my country. This is an example. We have the real example. Less signal degradation. Optical fiber experiences less signal loss than the copper wire. The integrity maintains over here. No modification of the data is possible very easily, and there is a no um, disturbances, no interferences, because of which there is less loss of data. Light signals, unlike the electrical messages sent through copper wires, light signals from one fiber inside the fiber cable do not interfere with one another. So, as we have discussed in the copper wires and all, they will be having the disturbances. Okay, the other signals can interfere with one another. Okay, disturbances will create. So, but light signals from one fiber inside the fiber cable only, we have different light signals which is passing through. So the different light signals from one fiber inside the fiber cable do not interfere with one another. If you can see this diagram also, you can see lot of light is transmitting in this wire, right? So this particular light signal is not going to interfere with the other one. So there is no disturbance and there is no loss of data is possible. So this translates to a cellular clear phone calls or TV reception. So there are two live signals are passing parallelly. One is for phone calls and the one is for TV reception. See, they both can travel together because they will not interfere with one another and create the disturbances. So you can see we have a very smooth communication or the smooth communication. Yes, channels we can watch in the TV, and there is a smooth connection provided to the internet also. So the two communications are going on. Two, if you can see in general terms, I'm talking about two light signals are passing. Suppose one for phone calls and the one for TV reception. So both are not interfering with each other. Long life optical fibers typically have a lifespan of more than 100 years. Are you all listening today? Why there is no response, students? When I asked you, do you have any kind of example like this in your country? Okay. Disadvantages, low power. On low power, a light emission source are available. So even though high power emitters are an option to boost power supply, the cost would increase over here. Okay, the cost will increase over here. Low power, because we are providing the high power emitters. So to boost the power supply to these cables, because of which the cost would increase. Fragility, they are more fragile than the copper lines because here we have used the glass. Obviously, glasses are more fragile than the other type of materials. So that's the reason it's very important to handle them with the care. It's very important to make sure that they don't get twisted or bent too much. Otherwise, it will harm the cable. Though we have the protective layers, but then it may harm the uh, fiber optic cables very easily. Distance. Repeaters are required. Repeaters means this is a device, actually network device, we say repeaters, and this network device here. Okay, this network device here called as repeaters. So when you are working for so long, for example, you are working from today, for example, 4 o'clock in the morning, you have got up and you are working to get, means you are continuously are working till night, for example, 9 o'clock or 10 o'clock. So you will get tired, right? So in between, what will you do? You take a 10 minutes nap, or you'll take a rest, or you take some energetic drinks. Okay, right? For what you are doing all this, to have or to eat the nutritious food in between. Okay, or some energetic drinks you are drinking, right? So all these things you do for what? To boost up your energy. So anyhow, when you're working continuously, our energies will go down. See, in between, we will be taking some of the consumptions we are doing so that our energy will boost up and we can able to work in the continual manner. So, right, so we have to strengthen our energy, or we have to boost our energy for continuously working for the longer time. So, distance over here matters. When you have a long distance communication, the signals, when the signals are transmitting from one device to another device, and when it is very long distance it is covering between transmitter and the receiver, then the signals become weak after some distance. After traveling the some distance, the signals will get weaker. So we have to strengthen the signals. We have to boost the signals once again. You have to give some kick or energy pass. We have to pass to this signal so that they will get the boost up, and they'll get the strength. Again, they'll travel in the same way. Okay, so the repeaters here we have, like how we have the energetic drinks over here, instant energetic drinks here we have to drink and then get the energy, or we have some meals, right? Same way, repeaters here we have who is providing this energy or strengthening the signal for the long distance communication. Am I clear? So this repeaters are required over here. This is what I'm talking about, and that is the disadvantage here we have. Applications. Nowadays, everywhere we are using fiber optic cables. Medical industry. Optical fibers is used to observe the inside parts of the body because it is incredibly thin and flexible. So additionally, it is utilized during operations to convey light to the inside. You can see endoscopy. Have you seen the endoscopy? Additionally, optical fibers is useful in dental applications also. Have you seen the endoscopy? There also one light bulb is there. You see, when it is going, it's connected with the camera also. When it is going inside from the mouth or from the nose or something, the wire will go. Okay, and from the mouth it is going to your stomach or somewhere they will take some organs they will take where you what they actually they want to test. So when they take, there also we will use a fiber optics cable where the cameras are fit and small light is fit. There also we use this fiber optics cable. Endoscopy or dental treatments when they are doing, also they use this fiber optics cable. Communication. The main usage of optical fiber is in telecommunication. It delivers a signal faster and with more accuracy as compared to the copper lines, because of which we are using the communication, whether it is a long distance communication, also it is covering uh, with the same speed, okay, and with the same correctness, same accuracy. Because fiber optic cables is constructed of plastic and glass, it is lighter and more flexible than the other materials, making it more simple to handle. Defense. As we all know, data security is especially crucial in the defense sector, right? So the ideal option for this is to use the optical fiber because here we have the more security provided to these cables if you compare with the other types of cables, because it lowers the possibility of data leaking to undesirable parties. Okay, data leaking is less, like how we have seen T-joint attackers can able to attach the T-joint to your communication wire, and they can able to leak the data, or they can able to compromise the data whatever it is passing through that wire. So here fiber optic cables, it is not very easy to do that because the data leaking is very less. High security has been provided to these cables, and because of which any unauthorized users or the undesirable parties cannot able to peep into the communication between two parties going on, cannot able to compromise the data of the transmissions going on between this fiber optics, through this fiber optics cables between the receiver and the sender. And we are using the internet also. In the internet, a worldwide internet, www, the fiber optics cables can be used to provide the internet since it can able to transport the vast amount of data very quickly. Computer networking for LAN, MAN, WAN, PAN, everywhere in the same building. If you want to provide the connection, or or you're providing the connection to a same city or different cities, whatever it is, we are actually using these cables for the networking purposes, same as internet. Car industry, lighting and decor industry. I have shown you this decor industry. decor, the lights, optic decor using the fiber optics. So car industry, what they are doing, they an ECU controls the many parts of a modern cable vehicle. Sorry, modern car vehicle. A quick communication system must be established between the different parts of the car. You have different parts assembled in the car, right? This different parts also require some communication, some collaboration, some cooperativeness, so that they can able to communicate with each other. A quick communication system must be established between them. The optimum material for this is fiber optics cable. Now it improves the car's safety and security both. Okay, and the communication also will happen very smoothly between the different parts of the car vehicle using this fiber optics cable. Even we are using the fiber optics cable for transparent material. It serves as a illuminating the space. Decorative purposes also we are using it. So any doubt so far, students? Any examples do you want to give about the fiber optics cable? Students, no activeness today, no communication. What happened? Yes, what happened to you all? I was not copying, I don't know. This is only the example I have provided to you. Okay, this is only the example. Decorative purpose, they said, right? And this is what the decorative purposes they are using it. Okay, no doubts. No examples do you have of fiber optics? Do you have any examples? Do you have any scenarios? Lot many things we have discussed about fiber optics cable, right? Don't have anything to discuss. Fine, then we'll continue with the next one, which is microwave transmission. Okay, microwave communication, microwave transmission, we will start. Anyhow, you're not communicating with me today. Well, I don't know. All are in the mood of rest or something. No doubts. I know you no doubts. But then no communication also on the example part. Okay. What is microwave transmission? Sending and receiving the information using a microwave is known as microwave transmission. Sending and receiving of the data is happening through the microwave signals. Using that, when we do by using microwave signals, when we do this transmission, is called as uh, microwave transmission. Now, I'll show you one thing over here. If you can see this diagram, types of transmission media, we have guided, which we have done these three. Okay, these two are least used, so we are not focusing on this. Unguided media, if you see, we have radio waves, microwaves, and the infrared waves. Okay, these are the signals we say, using which we do the communication, and here we don't use any physical medium. Okay, physical medium we are not using from one device to another device. It's like a physical medium means there is no physical cables or wires here we are using. Okay, it's what called as unguided ones. So in the example of the unguided ones, we are focusing on the microwave signals. So when we talk about the microwave transmission, That means the sending and receiving the communication is taking place using the microwave, is known as microwave transmission. Okay, so it is a transmission of information. What transmission you can do, what messages, what communication you can, in what ways you can do the communication, voice communication, data, television, telephony, radio signals, by microwave signals. All these types of communication, all these types of information can be transmitted from one device to another device. Microwaves are widely used for point-to-point communications. Okay, point-to-point communications, they are usually used.
Yes.
Microwaves are usually used, widely used for point-to-point communication. Yes, Wilson. Properties of microwaves, if you see, it is a wave that radiates
Oh,
electromagnetic energy. Sorry. Okay. So it's a wave that radiates electromagnetic energy with a shorter wavelength. Okay, and we can able to do the communication in the shorter distances very well with the microwaves. Not only shorter, longer also can be happen. So it is a wave which is radiating the electromagnetic energy with a shorter wavelength. Here we're talking about the wavelengths now, because these are signals without the physical cables. Microwave links consist of a transmitting station, a relay station, or repeaters. Okay, transmitting station called as TX, relay stations or repeaters called as RPT, and the receiving station called as RX. So repeaters are called as RPT and the receiving station called as RX. So repeaters are also called as relay station. Okay, transmitting station is TX, receiving station is RX, and the relay station or repeaters is RPT. Microwaves travel in light lines, in straight lines, in straight lines. So stations should be aligned to each other. So I'll show you one diagram over here. If you can see, this is how the transmission will take place. Transmitter here we have the receiver, and there is a transmission line. You can see these are towers. Okay, and when the transmitter has to send the data, it will travel through signals, we know, right? So this tower, when I'm sending a data from this tower, for example, general terms, again I'm talking about all the technical terms I'm talking about. So we have different towers like this. Between these two towers, a communication is taking place, for example. So this should be in the straight line. They should be in the same level so that the communication can happen. You can see this how the communication is happening from here to here. They should be straight enough. The size of the people should not be less. If they are shorter than me, I have to see like this and I have to speak, right? If it is longer than me, I have to see like this and I have to speak, right? But that communication is not possible in the microwave transmissions. When the people are the same height, like this, side to side, point to point, side to side, when we see, then only the communication can take place. That is a property here we have. That's what they are saying. Microwave travels in the straight lines. So stations should be aligned to each other. So the transmission is happening in straight lines. So the stations, the towers should be aligned with each other. It should not be here or it should not be here. This one. Otherwise, the communication cannot take place over here in the microwave transmissions. Now, microwave links require clear LOS, clear line of sight, as we have discussed already. So, antennas are installed high up to avoid the interference or obstacles in their path. So, towers are very huge, you see, it's very high. Antennas are installed very high to avoid the interference or obstacles in their path. They do not pass through buildings, thus reducing the efficiency of inside receiver. So they cannot cross any obstacles. That's the reason, to avoid the obstacles or the interferences, we will install this antennas in the huge big buildings. Okay, very huge in size. Otherwise they can't pass through the obstacles. They can't pass through the buildings or anything. So if it has to pass through buildings, then it will reduce the efficiency of the microwave signals. They are unidirectional and allows the multiple receivers. So one transmission is one one antenna is responsible for sending the data, and it is unidirectional, one way direction, we can say. It is sending a data and all others are receiving, only receiving the data. Okay, like for example, you are speaking and I'm only listening. Okay, that is what called as unidirectional. Only you will speak, I'll just only listen. The same way they are sending and others are receiving. Okay, so they have multiple receivers, multiple hearers who are multiple listeners, but only one person can send a data. It's called as unidirectional. They are unidirectional and allows the multiple receivers to receive the data. Receivers are added. Okay, receivers are added to boost the power of the signal so that it can't able to travel the it can able to travel the longer distances, as we have discussed. Repeaters, like we have repeaters to boost up the signal, to boost up the strength of this signal, right? Same way that in the physical cables we have seen, the fiber optics cable we have seen, to strengthen the signals, we have the repeaters in between installed to pass the strength, to pass the energy to these signals. Okay, same way we have the receivers over here. Receivers are added to boost up the power of the signal so that it can able to travel over the long distances. They're also refracted by atmospheric layers. Thus, refracted rays take more time to reach the destination than direct rays. They're also refracted. Refracted means because of the atmospheric layers, we have they are refracted, and thus refracted layers can take more time to reach the destination than the direct rays. Okay, so it will take little time. Microwave are unidirectionals. We have discussed already. Okay, it's a summary kind of thing we can say. Characteristics of microwave transmissions are microwaves are unidirectional. Microwave transmissions involve light line of sight communication technology, affected greatly by environmental factors like rain fading, etc. For example, if it is a rain happening, the signals become weaker. You see, you might have experienced that, right? Because of rain, the communication nowadays, yes, it has been eliminated, all such kind of things. But earlier and all, if you see the uh, connection, okay, we will say the internet connection is poorer today, right? Because of what? Because of some factors, some external factors, some environmental factors, we will say. For example, rain. For example, it's storm. Okay, there's a lot of storm outside, lot of wind, storms, okay, because of which it's getting affected. Because that it is the communication is happening through the antennas, through towers. Obviously, this will be affected. Now, microwave signals cannot penetrate the obstacles, cannot pass through these obstacles, such as your hills, buildings, and trees, due to their higher frequency. Okay, so they cannot penetrate, because of which they have to be installed higher and higher in higher ranges, higher buildings. So it cannot penetrate through obstacles. For example, for example, buildings here we have, even trees, they can't able to penetrate buildings, hills. Okay, this kind of obstacles or different types of obstacles, if you take also, they can't able to penetrate. See, similar to this. So signals can be degraded using the during the solar proton events. Signals will be degraded. No signal, we will say. Signals, less signal, we will say. Because of solar proton events, also this may be degraded. Atmospheric disturbances. For example, your rain, snow can scatter the microwave signals. Atmospheric disturbances, for example, your rain, snow, storms, etc. Wind can scatter your microwave signals. These are the general properties and characteristics of the microwave signals. Any doubt so far, students? Just give me a moment. Any doubt, let me know. I'll connect my charger. Okay, we will proceed with now. And here, the general properties of microwave transmissions we will see. The general properties of microwave transmission are as follows. Configuration, okay, arrangement, configuration, arrangement, and setting of transmission equipment. For example, your antennas, towers, and whole network design is known as configuration. Configuration means design, okay, setting up the transmission equipment or arrangement of the transmission equipment. Transmission equipment means the equipment using which we are transmitting a data from one location to another location. So the configuration means arrangement and setting of these transmission equipments. For example, your antennas, towers, and whole network design is known as configuration. Bandwidth. It is a measure of the width of the frequency range. It's a measure of the width of the frequency range. It determines the rate of data transfer. Bandwidth, you know, how much data I can able to send at one time is called as bandwidth, right? So it is a measure of the width of the frequency range. It determines the rate of data transfer. Error. Due to interference and obstacle disruptions can occur in data transmission. We know lot of disturbances here we have. They can't able to penetrate the obstacles because of the environmental factors also. The signals are getting affected, because of which inaccuracies of the data transmission will happen. They may contain some errors also. Due to interference and the obstacle disruptions occur in data transmission, the inaccuracies are known as errors. The errors may be present in the microwave transmissions. Though it is very much useful nowadays, but then there are some disadvantages by using the microwave transmissions. That's why we are moving to satellite communications and all. So performance. In microwave transmission, the successful transmission of data in terms of speed, latency, reliability is known as performance. When you say it's a high performance, when the speed is very high, very good, okay, the bandwidth is very good, latency, reliability means the signals are not having much errors, okay, accurate data they are passing is called as reliability. And in terms of all these factors, we decide the performance of microwave transmission. We talk about the terms of distance. The maximum span over which the microwaves can effectively transmit a data without weakening the signals is known as distance over here. So the distance when I talk about, obviously the signals will go weaker. Weakening of signals will happen, but the maximum span over the microwaves over which the microwaves can effectively transmit a data without weakening the signals at all is known as distance. It can able to travel the long distances very easily without weakening the signals. Security. Production of data from the unauthorized access is possible or not. We have to decide over here. Now, how we will say security in terms of protection of the data from the hackers, from the unauthorized users, or interception means peeping into a data, looking at your data, sensitive data is called as interception. So no interception and no unauthorized user can able to access your data in microwave transmission is known as security. To what level of security you're providing to microwave transmission is different. But if you talk about security in terms of what, if you ask the security in terms of protecting the data from the unauthorized users, and what level of security we have in microwave transmissions, it is over and all over. It is increasing the security. Don't worry about it. So cost, the financial investment required for installing or configuring this type of installation, or is your configuration in terms of your arrangement and setting of your transmission. The cost, how much it is incurring for configuration process and for maintaining a microwave transmission systems, including your equipment, licensing, operational expenses is known as cost. That is what the general properties here we have discussed. Now, next one here we are going to proceed with process of microwave transmission. Okay, what is the process of having the microwave transmission. The process at first, the signal to be transmitted is processed. The signal to be transmitted is called as baseband signal. Please remember these terms. At first, the signal, whatever we are transmitting, the signal to be transmitted is processed. The signal to be transmitted is called as baseband signal. Is processed or encoded at the transmitting station. Okay, is processed and encoded at the transmitting station, because this is the station using which we are transmitting the data. This is a transmitter and this is called as transmitting station. So here is the one, actually the baseband signals are being processed and encoded. What do you mean by encoded? Any idea, students, what do you mean by encoded? Quickly, fast, encoding. We have different layers like OSI layers, TCP/IP layers, right? So encoding the data to be transmitted or framed according to the data, according to the format using which a transmission will actually happen. Okay, encoding whatever data here we have, we are actually encoding at transmitter station. The encoding means a process of converting the data into the particular format of sending the data into signals, I can say. For example, your electronic signals, the data is transmitting your electronic signals for the physical medium. Same way, for transmitting a data in fiber optics, converting into the form of light. Okay, same way you have to encode in what way you're sending a data, and in terms of security purposes also the use is encoded. Okay, they will encode this data. So signals to be transmitted is processed and encoded at the transmitting station. Then it is used to modulate an intermediate carrier of 70 megahertz or 140 megahertz. Okay, it is used to modulate an intermediate carrier. The carrier is the one who's actually carrying your signals. It is used to modulate an intermediate carrier of up to 70 megahertz to 70 megahertz or 140 megahertz. Then the modulated signal is up converted to the microwave frequency. The signals which are modulated, okay, that is again converted into microwave frequency. Then it is amplified before being fed to the antenna for radiation. Again, the amplification has been done to this signals before feeding it to the antenna for radiation. Then we have repeaters placed at several points are used to boost the power of signal. We have discussed on this. Okay, what are repeaters and what they use for. Repeaters can be of two types. One is active receivers or passive receivers and passive receivers. So repeaters means these are the devices which is strengthening the signals, giving the energy to these signals, boosting the power of the signals. So repeaters are of two types. One is active receivers and the one is passive receivers. Passive repeater or receiver, they are a beam, okay, diverters. They are beam diverters to make the beam pass the obstacles using several parabolic antennas connected by the section to the waveguide section of the waveguide. They do not have any amplifying devices. Active repeaters means they includes an amplifier for boosting the signal strength, and they also have the frequency translation circuits to change the frequency of the signal before retransmitting it. It is called as active repeaters. Got it? What is passive and what is active? So passive, they are beam diverters. Active repeaters includes an amplifier and for boosting the signal strength. Okay, and these passive repeaters, they are using the beam diverters to make the beam pass through the obstacles, okay, using parabolic antennas. Here they are using the amplifiers for boosting of the signal strength. They also have the frequency translation circuit to change the frequency of the signal before retransmitting it. Now at the receiver station, the signal is down converted to 70 or 140 megahertz. Then it is demodulated to recover the baseband signal. What are the antennas we have used for microwave transmissions? Antennas can be defined as a transducer between the guided and the unguided media. Okay, so it transforms the energy between the free space and the guided media, for example, your cables or waveguide. Antennas can be divided into further types. One is parabolic dish antenna, another one is horn antenna. Parabolic dish antenna I have seen. Okay, I think you all have seen also. You all have also seen this. So they are used at the receiver end of the transmission link. Okay, receiver end. Where which end? Receiver. This end. Receiver end. This is sending. This unidirectional I said this is sending, and this is the antenna which is receiving the data at the receiver end will place it. So they are parabolic in shape. That is why it is called as parabolic dish antenna. They permit the greatest focus of energy possible in a single beam. So parabolic antennas are highly directional. Okay, horn antenna. You can see this like a kind of horn only. It is a radiating element in the shape of a horn with a stem, and its one end is flat out to improve the efficiency. Radiation is poor and non-directive. It's called as horn antenna, non-directive. Here this is having a direction, but here there is no direction, non-directive, and this is directional. And the radiation is poor and the radiation is good over here in the parabolic antenna, because of which now also you see I have never seen any horn antennas. We have only seen the parabolic antennas because these are very good compared to the other types of antennas for receiving the data from the signals. The advantage of microwave transmission, cheaper as compared to the radio waves, supports larger bandwidth, so more information is transmitted. They are used for point-to-point communication. Point-to-point line of sight communication will happen. More antennas gain is possible. Okay, more antenna gain is possible. More antennas you can able to install in it. Antenna size get reduced as the frequency is higher. Okay, so lower power consumptions as signals are of higher frequency. So if you have a higher frequency, the antenna size is smaller. Nowadays, the big before and all antennas are very big, but now the antenna sizes has been reduced because the frequency is becoming higher and higher. Low power consumption as signals are of higher frequency. The effects of fading gets reduced by using the line of sight propagation. Line of sight propagation means side to side, point to point. Okay, the towers, the stations have been installed in such a manner that is a line of sight is that. So no signals are uh, moving here and there. So it's like a sight line of sight. So the effect of fading the effect of fading get reduced by using the LOS called as line of sight propagation. Do not require any land for installation of cables. Don't require. We require some space for installing the towers and the antennas. Okay, configuration. Easy communication over rugged terrain. Okay, easy communication can happen. And communication over oceans is also possible. These cables are not go under oceans, right? So it's not possible. So communication over oceans also is possible because of this microwave signals. Then we have these advantages. The cost of equipment or installation cost is higher. Susceptible to weather conditions, obviously environmental factors are affecting the signals. Eavesdropping to some extent. Eavesdropping means the unauthorized user trying to access your data over the communication. So it's called eavesdropping. So it everywhere, though you are providing a high security, everywhere data breaching is possible. Eavesdropping is possible. So here also to some extent, eavesdroppings will be there. Security is again in one risk. Okay. Limited bandwidth between 300 megahertz to 300 gigahertz you can transmit a data at a time. Applications, if you can see, Bluetooth, in Bluetooth, communication is done through ultra high frequency UHF radio waves. Bluetooth. Wi-Fi, when Wi-Fi data is transferred using microwave. In Bluetooth communication also, the communication is done through the ultra high frequency, which is done through the microwave signals than the radio waves. Okay, that is your microwaves only, ultra high frequency. Talk about the microwaves only. So in Wi-Fi also data is transferred using microwave. Direct broadcast satellites. Since microwaves are able to pass through the atmospheric layer, the communication is done through satellites. Okay, direct broadcast satellites can happen because of this microwave signals. GPS. Microwaves are used in order to locate the locations. You can use these microwaves. FM radio. We have the microwave transmitter and receiver to use the transfer information from through a line to other line. Satellite TV. Since microwaves are able to pass through the atmospheric layer, so the information passes from TV to satellite and vice versa. From satellite to TV and TV to satellite is possible because of this microwave signals, because it can able to travel through the atmospheric layers. Okay, so types of microwave data transmission system, we have of two types. One is terrestrial transmission and the other one is satellite transmission. Terrestrial transmission looks like this. They can't pass through any obstacle. That's why you see there's a line of sight. Signal propagation is happening between line of sight. Okay, they have installed properly so that they can have the communication. They use directional parabolic antennas. They are using the parabolic antennas, which are directional in nature. Signals are high focused. Line of sight transmission is needed because you see line of transmission, otherwise here and there they can't able to communicate, and their path should be free from any obstacle. They can't penetrate through any obstacles. For long distance transmission, signal strength weakens. Okay, so we require the repeaters. So repeaters are used for every 35 to 40 kilometers. It's called repeaters. To strengthen up the signals, we require repeaters. So repeaters are used for every 35 to 40 kilometers as such on the earth. You can see this is transmit antenna and this is receiver antenna. Advantages of this particular terrestrial transmission is they are used to carry thousands of voice channels at the same time, and transmission rate of the data is 16 GB, that is gigabits per second. Disadvantages: installation cost is very high. Maintaining a LOS, you see, maintaining the line of sight and the obstacles is difficult over here. Obstacle free path is difficult over here over the long distances. It's very difficult, right? Yes, it's difficult. EMI effect and jamming effect the signal strength. Okay, jamming effect, EMI effect, environmental is going to affect. Application: cellular phones, television, telephone. This terrestrial transmissions are happening using in these applications. It's happening. Then we have the satellite transmission. Terrestrial transmission we have discussed. Next one is satellite transmission. We will discuss now. Now, satellite transmission, microwave relay station is placed in the outer space. You can see this is the Earth, and this is somewhere the satellite over the sky. Okay, so microwave relay stations here we have, you see, first Earth satellite, second Earth satellite. So these are the relay stations. Is placed in outer space. Satellite is launched using the rocket or space shuttle in the space. Satellites are precisely positioned where 360,000 kilometers above the earth. 360,000 kilometers above the earth. Orbit speed matches the earth rotational speed. The orbit speed of the satellite the orbit speed of the satellite has to match the rotational speed of the earth. The satellite is stationary relative to earth. Advantages: single microwave relay station visible from any point in a larger area. Transmission and recipient's cost are independent of the distance between the 2 points. The transmitting station can receive back its transmission and check whether satellite is transmitting the information correctly or not. They can check the correctness of the satellite working, satellite process or not also can be checked, okay, using the satellite transmission communication. Disadvantages very high. You see, you have to place a satellite, okay, using the rocket or space shuttle in the orbit. Okay, you have to align the speed of the satellite orbit with the rotational speed of the Earth. Okay, this kind of extra high cost of placing. Okay, the signal is sent to satellite broadcast to all the receiver satellite which are falling in the range. Security measures, again, people can able to peep into your data communication. Unauthorized tampering of information is possible. Usually used for broadcasting and receiving the signals, we use satellite communication. Okay, any doubts so far, students? No doubts? Hoping that they don't have any doubts, I'm proceeding. Microwave propagation and path losses. When the signal propagates, even a slight direction LOS, slight change in the LOS link beam can cause loss of data in transmission. These losses are known as path losses. One is free space path loss, atmospheric absorption loss, and diffraction loss. Free space means is typically the largest portion of path loss because of this obstacles we have, because of which the data will be lost. It is the effect of the signal spreading out as it propagates from the transmitting antenna. Now, these losses are directly proportional to the link's distance and signal frequency. When these two increase, the path loss increases. Atmospheric absorption, both oxygen and water vapor present in the air attenuate the microwave signals. When the link length increase, the loss increases. Atmospheric absorption. Okay. I think this diagram. Absorption it is. Atmospheric absorption because the oxygen and the water vapor present in the air, because of which is attenuate the microwave signals. Diffraction is yet another cause of path losses. Path reliability in microwave transmission. Considering all the path loss factors, we can quantify path reliability is known as path availability. Due to poor propagation conditions, the path fails to perform and data transmitted from one end is not successfully received at the other end. So path reliability means that path availability is a measurement of the path ability to reliably communicate the data over years and years. Path performance can typically be improved by increasing the overall system, by increasing the power, reducing the loss in transmission lines, and increases the size of the antenna itself. You can do all these things for increasing the reliability of the path and have the accurate data in the receiver side. This is what called as we have discussed about the microwave transmission. Okay, is it clear by everybody? This is the end of the chapter today. Any questions you can ask, otherwise we'll wind up the session. Any doubts so far?
No, miss.